Hello, today we're going to be looking at Lesson 8. So, I guess you've already figured out the page numbers are a little wonky here. But as long as you follow along every day, you should be fine. Now, looking at Lesson 8. Applying the properties of operations to add and subtract rational numbers. So today we'll be talking a lot about properties, and we'll continue to do that tomorrow. We're going to use properties to make our math easier. Properties, and the reason we're doing that is to make it easier. The properties aren't just something that some math teacher came up with to make you work harder and have something else to memorize. The intent is to make your math easier. So, we're going to start with this example. This wording is atrocious. The opposite of a sum is the sum of its opposite. So we're supposed to explain the meaning and use a specific math example. So my math example is going to be starting out with 7 and negative 2. So if I have 7 plus negative 2, the sum would be positive 5. Now, the opposite of the sum, the opposite of 5 is negative 5. Okay? And then I want you to do the opposite of this number would be negative 7. The opposite of this number is 2. And the sum of those numbers, negative 7 plus 2, is negative 5. So, the sum of the opposites is the opposite of the sum. Basically, what you're doing here is just distributing a negative 1. Okay? So, if I had 7 plus negative 2, but I was doing the opposite of that, the opposite of this sum, it would be negative 7 plus 2, which would be negative 5. Okay, we'll be using that. It's okay if you're still feeling a little what about this right here, because we'll continue to use it, and you'll catch it as we go. So, moving forward, we have an exercise here. We're going to represent the following expression with a single rational number. Now, on this copy, hopefully yours printed, but there's supposed to be a subtraction sign there. Hopefully it printed on yours, but it didn't print on mine. So add that subtraction sign in if it wasn't there. See, that was the original right here. That subtraction sign should have been there. Whew. Okay. So when I'm looking at this, and that's a plus sign. This did not print well. Okay, when I'm looking at this, first of all, I'm feeling a little overwhelmed because there's fractions, there's positives, negatives, all this stuff's going on. So I'm asking myself, is there anything I can do to make this easier? Well, I'm thinking maybe I want to put my negatives together. And if I do that, oh my goodness, they also have a common denominator. This could make it easier. Let's try. So what I'm using here is the commutative property, which allows me to change the order. Notice I keep the sign, this minus, I keep that with that, okay, with the term behind it. Sign stays with the term behind it. So I use I always forget how to spell this one, commutative property, to switch the order. Now watch what happens. I should probably rewrite this as an addition problem. So, whoa, I'm going to add the opposite, because that's the same as subtracting. That's just right here. I'm going to do that. Negative 2 and 2/5 plus negative 3/5. Make it pretty, well, organized. Let's not say pretty, I guess. Now I'm actually going to, adding the opposite is subtraction. So I just rewrote that. I rewrote this part as that. Okay. Now, I'm actually going to do this part. So negative 2 and 2/5 plus negative 3/5. So when I add that, same denominator, so that's going to be negative 2, and then 2, negative 2 plus negative 3 is negative 5. 5 is the denominator. So that's going to be negative 3. Okay? And I'm just going to bring that down. Bring it down again. Now here's what's... Whoa. Sorry that you couldn't see that. Okay. Here's what's beautiful. Okay? When I rewrite this negative 2 and 5/5 is negative 3, watch what happens if I just kind of break this down. Negative 3 plus 3 plus 1/4. And I did that so that I would have, right here, additive inverses, because that makes 0, which means I have 0 plus 1/4, which is 1/4. I need to go back and put in the things I did. Okay, so what did I do? Right here, I just simplified that fraction, and I used additive inverses. Okay. Oh, and I went from 3 and 1/4 to 3 and 1/4. That is called decomposing the number, because I wanted to keep that 3 here separate from the 1/4 so I could combine those. All right. So, I mean, it's a lot of writing here, but this writing is me making my thinking transparent so that you can see it on paper. And it really made it easier when I used these properties. So let's look at another problem. All right. Make sure we're lined up. Good deal. Use the number line model shown below to explain and write the opposite of 2 and 2/5 as a sum of two rational numbers. Okay. The opposite of this would be, okay, so here's 2 and 2/5. The opposite of that is negative 2 and 2/5. Okay, so hold up. What is happening here? We have 2 plus 2/5. So 2 and 2/5. Okay, so the opposite of that is a vastly different color. Hot pink, yeah. So notice this is 0 here. So that's negative, the opposite of 2 and 2/5, or negative 2 and negative 2/5. So the point here is that you recognize this 2/5 is also negative. So if you've got negative 2 and 2/5, you've got negative 2 and negative 2/5. That's important to know because a lot of people get confused and they think that negative 2 and 2/5 means negative 2 and positive 2/5, but that's not correct. It's negative 2 and negative 2/5, as you can see by this arrow here. So, oh boy. Rewrite each mixed number as a sum of the two signed numbers. So this is not going to be difficult. Why don't you pause the video and you try it on your own, and then we'll look at it together. And we're back. Okay, so this would be negative 9 plus negative 5/8. And this set of parentheses here just helps to separate the addition sign from the negative sign to make it neater. That is the purpose. Negative 2 plus negative 1/2. Make it neat. You could also put this in parentheses if you wanted. It's not necessary, but you can. Okay, then we have positive 8 and positive 11/12. Just like each piece here is negative, each piece here is positive. So, the more you know. working exercise 3. Now we're doing the reverse. We're representing each sum as a mixed number. So this is -1 and 5/12, 30 and 1/8, -17 and 1/9. This feels slow, but this is important, and it is really a place where lots of people mess up. So it's worth the time. All right. We're going to find some mistakes, I think, down here. Yay. I love doing that. It really helps you learn and make sure you understand it. But let's not get ahead of ourselves. It is exciting. Mr. Mitchell lost 10 pounds, and then he gained 5 1/8 pounds. So I'm supposed to use an expression and then find the overall change. So this is the expression. To make it easier, I'm going to do like this. I'm going to say -5 plus 5. Whoops, plus -5. -5 and -5, I decompose that. Plus +5 plus 1/8. Now look here. This cancels. I have -5 plus 1/8, because that was a positive 1/8. So that's -4 and 7/8. All right. Oh, the overall change. That is his change. He lost 4 7/8 pounds. Okay, Jamal's completing a math problem. Justify each of his steps, then show another way to solve the problem. Oh, we're not looking for a mistake. Okay, so what changed from here to here? Oh, actually, initially, it said -3 2/7, and then here it says plus -3 2/7. So that is because subtracting is adding the opposite. Okay. Then here, these two things have switched places. For down here, we can do that because of the commutative property if we're dealing with addition or multiplication. All right. Then he's broken this down, and additionally broke this down. We call that decomposing. Okay, then what's happened here? Switch the order of these two. Whoops, switch the order of those two. That's the commutative property again. Ooh, okay. Then these two have been combined. So that's just evaluating or solving. Oh, I'm getting ahead of myself. These two, it's evaluated, because -5 and -1 is -6. And these two, I evaluate that, I get -9, -6 and -3. And finally, those two, and that evaluate, we can also call that combine like terms. Okay. Yay! That's good. Now we're ready for our problem set, which is a different video.